Math 1343, Week 3, Video 3, second example of estimating one population mean. Let's get right into it. Soda Bottling Company has a machine that is supposed to fill each bottle with 20 ounces of soda. Quality Control Department checks monthly to see if this machine is actually filling each bottle with 20 ounces. To do this, they take a sample of 100 bottles and constructed a 99% confidence interval for the mean contents for all bottles. If the interval excludes 20 ounces, the machine is shut down and recalibrated. In the most recent sample of 100 bottles, the mean content was 20.4 ounces with a standard deviation of 0.2 ounces. Should production be shut down? And it just dawned on me that everywhere it says ounces, it should say fluid ounces, but let's not nitpick it. All right, so this looks like a rather long word problem, but it's actually pretty straightforward. Despite all the words, we're being asked to build a confidence interval for a population mean, which means we need to extract the given information necessary. But unlike the previous example, once we get our answer, we need to use it to determine whether or not this machine shut down and recalibrated. So let's go through the problem and extract the information that we need, and then we'll build our interval. There's a lot of words here, and you would think that the 20 that we're given at the beginning is a value that we need, but it's actually not. First value that we'll need is a sample of 100. And we're told that twice in generalities and then talking about a specific sample of 100. But no matter where you find it, we are given that n is equal to 100. That's nice because we square root that number in our formula for standard error, and the square root of 100 is just 10. And we're going to construct a 99% confidence interval, so there's our confidence level. Our confidence level is 99%. Comma. Let's see, if the interval excludes 20 ounces, blah, blah, blah. In the most recent, here we go. In the most recent sample of 100 bottles, the mean content was 20.4 ounces. All right, so that is the mean of a sample, and so that's X bar. X bar equals 20.4. And a standard deviation of 0.2 ounces. This is still from the sample, so that is sample standard deviation. That is lowercase s. Then we're actually not being asked to find the interval directly, but we are being asked if production should be shut down. And whether or not it's shut down depends upon whether 20 ounces is inside of that interval. So the implication is we need to find the interval, find the confidence interval for the question. This is just like the previous problem now. The only difference are the numbers that we're using. And really, that's the trick to doing most word problems, and in this case, confidence intervals. Find the information that's given, and then follow the steps. Step 1 is to find t. And since we're limited on space down here, I'm not actually going to write find t. I'm just going to do it. All right. So we have a 99% confidence level, which means 99% is in the middle. That means 1% is left over for the two tails, and if we divide that in half, that means that this area is 0.5%. But in order to look it up in the t-chart, we might want to go ahead and convert this to a decimal by moving the current decimal 2 places to the left with 0.005. For degrees of freedom, that's just the sample size minus 1. 100 minus 1 is 99. So let's go to our t-chart and find what that is. Have it open. The browser's open, but the tab is not pulled up. There we go. All right, so we're looking at a 0.5%, which is the second column from the right, the 0.005 column. And we need 99 degrees of freedom, so looking on the left, scroll until you get 99, but this chart is limited. Once you go past 75, you just use the infinity row. So remembering that we're using the second column from the right, one that represents 5% in the right tail, the infinity row, our t-score is 2.5759. 2.5759. 5759. So there's the t. That was pretty straightforward. Second step is to calculate the standard error. And in order to calculate the standard error, we just have to use the formula for it. The formula is standard error equal to the standard deviation, which was 0.2, divided by the square root of the sample size, square root of 100. I don't even need a calculator for this. Square root of 100 is 10. And when you divide something by 10, it moves its decimal place one place to the left. I'm going to get 0.02 exactly. Now, I'm not saying you shouldn't use a calculator on this, by all means. This is in the course in doing mental arithmetic. So by all means, use a calculator. But I just spotted an opportunity. Well, to be honest with you, I built the opportunity to not have to use a calculator. Step 3 is the margin of error, which is just the product of the t. So 2.5759 times the standard error, 0.02. And although I could probably do this without a calculator, it'll take a little bit longer. More chance of making a mistake, and I don't want to do that. So we'll just put the calculator. And we get 0.0515. Next digit is 1, so it will not round up. That's actually an approximation. Theoretical mathematician in me will not let me put an equal sign there if I focus on it. All right. Then, part 4, we simply take our point estimate, our sample mean, 20.4, and add or subtract the margin of error, 0.0515, and then write our answer in the form from the answer to the subtraction problem to the answer to the addition problem. 20.4 minus 0.0515 equals 20.3485. And the addition problem, if I can use my calculator correctly, the addition problem is 20.4515. So in terms of the steps for doing the confidence interval, it was pretty easy. But we had a question to answer. So let's answer that on the next page. The problem stated that if the interval excludes 20 ounces, the machine is shut down and recalibrated. And the question is, should production be shut down? Well, here's the interpretation of our confidence interval from the previous page. We state with 99% confidence that the mean contents for all bottles is from 20.3485 ounces to 20.4515 ounces. Notice that 20 does not fall in that range of values. Since 20 ounces is not in this interval, the machine should be shut down and recalibrated. Quality control is kind of important when you're manufacturing a product and make a claim about its contents. If I buy a 20-ounce bottle of soda, I expect it to have 20 ounces. If it had more than 20 ounces, it wouldn't bother me, but the company might be losing money. If it had less than 20 ounces, then it would bother me because I'm paying for 20 ounces and not getting it. So either way, whether the contents are too high or too low, there's a reason to shut down. All right, so it's a pretty straightforward problem. Just build a confidence interval and use it to answer